let's get started. Good afternoon, everyone. My name is Zhizhen Fu from Nvidia. So it's my honor to introduce generative AI in medicine and healthcare. And before we dive into our topic, let me briefly introduce Nvidia. So Nvidia is a computing platform company. So our mission is to solve the difficult problem that normal computers cannot solve. So as you can see, the background is our headquarters. So it's look very cool in Santa Clara. So let's go back to the around 12 years ago. So as you can see on the bottom, one of few small GPU cards can support the AlexNet, which has a parameter around 61 million parameters. And after 10 years later, as you know, GTP3 need to be trained and inference on this kind of supercomputer, which has multi-GPU and multi-node to provide a superpower for this kind of large language model with parameter as large as 175 billion parameters. So in order to improve the performance of our computing as many as around 1 million fold in 10 years, we need to reinvent our hardware, such as GPU and CPU. And also we need to integrate those hardware with software platform to get the best performance. In addition to that, we are also interested in next generation of computing, such as quantum computing. So with this kind of huge power computing capability, we are interested in some applications such as sustainability or generative AI, and also industrial digitalization. So I would like to share a video with you to give you an idea what kind of application can be added by AI.
I am an explorer, traveling across the Atlantic to unlock its mysteries, and back in time to understand the origins of the universe. I am a visionary, bringing sharper focus to researchers, and brilliant clarity to surgeons. I am a healer, making treatments as unique as every patient, and giving new life the chance to thrive. I am a guardian, looking out for dangers around us. And in the depths below. I am a helper, enabling healthier, more sustainable crops. Bringing them to market faster and preparing them for the table. I am a creator, building virtual worlds to help robots learn faster and make our connections stronger. I am even an avatar, and you can ask me any question.
Who made this song?
Ava used artificial intelligence to write this song, and it was recorded by the London Symphony Orchestra. I am AI, brought to life by Nvidia, deep learning, and brilliant minds everywhere.
So as you can see on the video, so there are various applications. But from the top application, we need several stacks of support from the hardware and software. So we call this kind of full stack end-to-end support for the developer. So as you can see on the bottom, we have hardware layer. So in the hardware layer, we reinvent our GPU, CPU, and also DPU, which is data process unit. And based on those process units, we build up our workstation or our server, such as RTX or DGX, and also supercomputer as well. So based on the hardware, we develop our system software. For example, RTX is for ray tracing technology, CUDA is for parallel computing, and PhysX is for physical simulation. And based on this software, we further create our platform. We have NVIDIA HPC or high performance computing platform, and we also have NVIDIA AI and NVIDIA Omniverse for generate digital twin. So based on these three stacks, finally, we can support our developer with application framework. So we have 11 frameworks. From the left-hand side, as you can see, we have modules for supporting simulation. And today, we are going to dive into the second one, called Kara MONAI, which can support healthcare. And we have NeMo in the middle for LLM. And we also have Isaac for robotics, and so on. And for the developer, we can have this kind of framework support to facilitate the application development. So, and then I'm going to talk about three parts. The first part is about generative AI. Second part is how we use generative AI in drug discovery and also in medical imaging. So let's talk about generative AI. So the basic idea for generative AI is generating new data using past data. So we learn and understand the domain knowledge based on the past data. And therefore, the main idea is to generate original artifact that would look like the real data. So generative AI allows multi-model data type as an input. So we can input text, image, speech, code, or 3D object. And based on our foundation model, we can solve many tasks. For example, we can have Q&A, we can generate image, audio, UI, or 3D generation. And please note that there are two ways when we try to develop our generative AI. So on the left-hand side, some challenge of building foundation model is that, for example, for ChatGPT or for Llama, we need amounts of training data, and we need large scale of computing power or infrastructure, and we need deep technical expertise to build up the complicated algorithm. And on the other hand, we can also use or fine-tune our foundation model. But we need to take a note, there are some challenges as well. For example, like domain knowledge or for sensing in time. That means you can only collect your data in certain period of time. And that will bring out some drawbacks, such as undesired information or biased information. Okay, so let's go back to our topic. So generative AI is turning biologic from science to engineering. So as you on the left-hand side, the paper or publication in AI biology increased dramatically. You can see in here, such as AlphaFold or DeepDock for molecular docking. And on the right-hand side, there are many different applications. For example, we can have prediction on virus evaluation, or we can predict gene expression and predict complicated structures. And we can also generate functional protein and generate molecules. So I will have a whole picture about our Nvidia Clara for biomedical application. So on the left-hand side, you can see Parabricks, which is a framework can support genomics. And the second one we call BioNeMo can support drug discovery. And the MONAI for supporting medical image AI. And Flare can support federated learning, which is good for multi-hospital training model. So that allows shared model, not sharing data. And on the right-hand side, you can see the LLM NeMo. So the good thing of using our framework is that we can have good pre-trained models to speed up our training and optimize our inference. And also can use this tool by cloud service or by APIs. So let's go to the generative AI application in drug discovery. So I would like to share the video with you first.
Drug discovery is incredibly hard. Bringing a new drug to market takes more than 10 years and has just a 10% success rate. Between the complexity of biology and the near infinite chemical and protein combinations, discovering drugs to help cure disease is a truly heroic endeavor. Accelerating this process is mission critical for drug developers. There are 3 key stages to drug discovery: discovering the biology that causes disease, designing new molecules, whether those are small molecules, proteins, or antibodies, and finally, screening how those molecules interact with each other. Today, generative AI is transforming every step of the drug discovery process. Nvidia BioNeMo service provides state-of-the-art generative AI models for drug discovery. It's available as a cloud service, providing instant and easy access to accelerated drug discovery workflows. BioNeMo includes models like AlphaFold, ESMFold, and OpenFold for 3D protein structure prediction, ProtGPT for protein generation, ESM1 and ESM2 for protein property prediction, MegaMolBART and MoFlow for molecule generation, and DiffDock for molecule docking. Drug discovery teams can use the models through BioNeMo's web interface or cloud APIs. Here's an example of using Nvidia BioNeMo for drug discovery virtual screening. Generative models can now read a protein's amino acid sequence and, in seconds, accurately predict the structure of a target protein. They can also generate molecules with desirable ADME properties that optimize how a drug behaves in the body. Generative models can even predict the 3D interactions of a protein and molecule, accelerating the discovery of optimal drug candidates. With NVIDIA DGX Cloud, BioNeMo also provides on-demand supercomputing infrastructure to further optimize and train models, saving teams valuable time and money so they can focus on discovering life-saving medicines. The new AI drug discovery pipelines are here. Sign up now for access to NVIDIA BioNeMo service.
Okay, let's talk about the models for AI-powered virtual drug screening. So for the first step, we would like to have small molecule generation by using a model such as MoFlow or MOBART, this kind of AI model can synthesize or generate the small molecule. And the second part is we would like to transfer those small molecule data into three-dimensional structure by using generated conformer RedKits. And then on the middle button, we can generate or predict our protein structure by using some models, such as OpenFold, ESM-Fold, or AlphaFold 2. And based on that, we can start in the small molecule and the target protein docking by using the DiffDock model. So based on that, we can do the virtual drug screening by analysis this kind of docking property. And finally, we can have optimized molecule. So based on the BioNeMo, we can also customize our own model based on our own data. As you can see on the left-hand side, you can input your own model and you can integrate your own data into this framework for optimization, for model training, and also model fine-tuning. And also, we support the inference, such as protein folding or small molecule generation, and also molecule docking. And finally, you can design your own application based on your required pipeline. And this can be done on the Nvidia DGX Cloud. So to summarize the advantage of drug discovery with generative AI, so there are three advantages. The first one is you can customize your generative AI model by using your data or your model. Second is easy and instant access to optimized AI. And the third one is it's scalable. So depends on your budget, you can flexible using different kind of resource such as GPU and memory to achieve your pipeline goal. So the generative AI is not only for research, but also change the drug discovery industry. As we mentioned about on the left-hand side, there are many papers published over the last 10 years. And also, this example demonstrates you can save money and speed up your process for early drug discovery. So there are 3 steps for early drug discovery. The first one is find your target, such as your protein. And you need to have some lead drugs for screening. And third step is you need to do the optimization based on the docking result. And in the middle, traditional early drug discovery would take 4.5 years on average and spend over $500 million. By using generative AI, we can do the same job in 1.5 years and save money, so the cost can be down to $2 million. So overall, we can have 3 times faster and 200-fold cheaper than the traditional early drug discovery. And this data from in Medicine, our industrial partner. So our generative AI is on the right-hand side. We call in silico drug discovery based on AI and computer. But not only this, generative AI can be used on the first digital biology for genomics and proteomics as well. And also in the middle, you can see generative AI has potential to do the lab automation based on the sensor and robotics. So it's possible to have high throughput drug screening for the wet chemistry by using this robot arm. and with computer vision. Okay, so let's jump to the second part, generative AI in medical imaging. So let's talk about the MONAI. So in the middle, MONAI is a comprehensive medical AI framework built by experts and accelerated by Nvidia. So in the middle, we call MONAI application package, or we call MAP. So this MAP provides two functions. On the left-hand side, it's for model development. So it supports three main functions. The first one on the bottom is we call MONAI label. So MONAI label can support AI assistant annotation to save mass of time and manpower on the labeling. And on the left-hand side, we call MONAI core can generative census data and also provide some framework and also optimize for machine learning. We call Auto 3D. And on the top, we have a lot of MONAI model zoom to provide a lot of pre-trained model. So, and once you think your model is good enough for clinical usage, you can think about the application development. Deployment. So on the right-hand side, you can either deploy on the cloud or in hospital, or you can embed into your medical devices. So MONAI can support both parts. And here is some example I would like to share. As you can see in the middle, so MONAI can support different data from the biomedical world. First one is pathology. So as we know, pathology is a two-dimensional large data. We call whole slide imaging. And second, radiology. Radiology has three-dimensional data with a format we call DICOM. And also, MONAI can support the surgery, which has the video data. And on the right-hand side, you can see a lot of examples from the model zoom. For example, from model room, you can find some pre-trained model for supporting CT, MRI, three-dimensional synthetic data, and surgical video, and also pathology for cellular detection, segmentation, and classification. And here I would like to share this video about the generative AI in medicine, in medical imaging.
Generative AI is transforming healthcare with synthetic data, unlocking high-quality, unbiased data for medical device companies, pharmaceutical companies, and academic medical centers, leading to faster discoveries and improved patient outcomes. Generative models can help identify complex disease mechanisms, predict clinical outcomes, and prescribe tailored treatments for patients. MONAI, a framework for building and deploying medical AI, is also advancing generative AI with methods to create large synthetic datasets for training generalizable AI models that can learn from evolving patient data while preserving patient privacy. The latent diffusion model is a breakthrough in generative AI for medical imaging and is being developed by King's College London, co-founders of MONAI. This model can generate synthetic medical images of the human anatomy, including high-resolution brain images. It was trained on the UK Biobank dataset and Nvidia DGX Cloud in just 1 week, enabling researchers to control global and regional brain volumes and adjust for age, gender, and disease. Generative AI is already making an impact in clinical settings. King's College London and University College London have developed a novel transformer-based outlier detector that aids in clinical evaluation of deployed segmentation models. The results suggest that this approach can be used to ensure only expected and good quality data reaches downstream decision-making algorithms. Nvidia, Mount Sinai, and East River Imaging have collaborated to develop a new generative AI model for medical imaging known as RAD ImageGAN. By utilizing the StyleGAN XL model and training it on the RAD ImageNet dataset, RAD ImageGAN has become the most diverse synthetic data generator for 2D medical imaging. The model is pre-trained, robust, and adaptable to create other 2D medical imaging models, providing greater flexibility for medical researchers and professionals. Overall, generative AI models such as RAD ImageGAN and latent diffusion models are driving a revolution in healthcare. They provide high-quality data that can be used to train deep learning models, leading to improved patient outcomes and enhanced performance of medical imaging models. To access these models, visit the Nvidia NGC catalog or the MONAI Model Zoo. Ready to join the future of healthcare powered by generative AI? Join the MONAI community today.
Okay, so if you are interested in MONAI generative models, you can visit this GitHub. And actually, I will show you the GitHub after this presentation. And I would like to in this GitHub, you will find more material about MONAI generative AI tool, and you can find some tutorials about for 3-dimension or 2-dimension data, and also super resolution models. And you will see a lot of detail about MONAI Model Zoom. And there are 3 advantages for using this kind of generative AI in medical images. So first is you can generate realistic data set. And that will improve the accuracy of your model. And the second is you can either build up your own foundation model, or you can pick up some pre-trained model and fine-tune the models. And the third one is it reduces the privacy concerns. This is very important, especially if you have limited patient data. So this can help you to generate more data for training. And as you can see on the video, there are 2 main generative AI for medical imaging. The left-hand side we call RAD ImageGAN. It can support 3 different kind of models, such as data from CT or MR or ultrasound. And on the right-hand side, we call latent diffusion model. We are going to run a demo hands-on based on this model. And I will show you the more detailed information about this diffusion model. So the purpose of this model is it can generate high-resolution brain image. And we will run this model. Okay, so to sum up, MONAI solves 6 key workflows. So we only demonstrate the first part, generating synthetic data. And if you are interested in MONAI, you should figure out other 5 key workflows. The second one is we call AI assistant annotation to save your labeling time and power, human power. The second part is it can speed up your training. And the second, on the bottom, the federal learning can support multi-hospital modeling training and without sharing the data. And it can also translating AI model to application much faster. And once it's ready for clinical usage, it can support the deployment to the hospital. So you can find more detail on our Nvidia GPU cloud we call NGC. So you just Google Nvidia NGC and you can search MONAI here, or you can search BioNeMo here, and it will pop out a lot of useful material and information. And you can also go to the MONAI website for the detailed information about MONAI. So before I jump into the hands-on, I would like to show you about the GitHub. So if you're interested in the MONAI generative models, you can check out this GitHub. And today I would like to demo the one example from ModelZoom. And you can see there are a lot of models. And this one, we are going to practice. So you can see some information from the README about the author, text, and the model description. And you can also understand the model was trained on the brain data from around 31,000 patients from UK, and they use high-resolution 3-dimensional T1 MRI image and with certain resolution. And you can also find some reference paper here. Okay. And if you are interested in other models, you can play around with other examples. Okay, so let's go back to the, hold on a second. This one. Okay, so if you have this Google Drive, please go to this page and click this okay. And then connect to a GPU such as T4. Okay. So in order to save time, I would like to run all, and I will go through the code with you. So first step is install requirements. So we install the MONAI file and also the install the GitHub MONAI project, generative models here. And then we import and check our installation. So we import MONAI generative G-down for the Google Drive download, and also NumPy. And we would like to check the version of our MONAI, which is 1.3, and our generative version is 0.22. And then we go to the target direction and download the pre-trained model. Okay, so we download one autoencoder here and one diffusion model here. And one is around 50 mega and the other is around 2 gigabytes. And then let's generate some synthetic data based on those models. So here is an important part. So you can define what kind of brand you would like to generate. So in here, we define the gender. So 0 is female, 1 is male, and the age 0.7 means 70 years old. And we can also change the size of brain and ventricular here. And if you would like to change and play around the difference, you can change on here. So, and one thing I would like to note is that we need to replace this file path to the new one. And then we can keep going on running this one to preview the synthetic image. And then we can see our result here. So we can see a synthetic MRI brain with different cross-section view. And we also can change to, for example, let's say we would like to have a female and a little girl, 10 years old, and which like a smaller ventricular and larger brain. Again, we update the file path here. Then we have a new brand generated by AI with different condition. Okay, so please play around this and let me know if you have a question. And in the end of my presentation, I would like to share more hands-on material on our NVIDIA DOI, or we call Deep Learning Institute. And let me introduce my colleague, Herman, and he will go through the material with you.
Okay. Thank you, Qizhan. So in here, I would like to take maybe 5 minutes to introduce some additional training resource within NVIDIA. So in NVIDIA, our team is Deep Learning Institute. So our focus is to provide a training resource and education program to people who want to learn the AI or accelerated computing. So we will provide training content to individuals or different organizations, and that also includes educators and students. So I would like to take the opportunity to introduce some of the training content we have, and then you might be able to leverage this content to advance your learning. So in the platform, we have quite rich different content portfolio that including some fundamental training that may be 2-hour training, or we have also have the more advanced instructor lead hands-on that pick up the skill. And the topic we cover some fundamental deep learning foundation, and also we cover more for children share about the generative AI, or we have some conversational AI topic. So it quite cover a lot of quite different, we say accelerated computing related topic, or we also have some application domain like the anomaly detection for manufacturer, or we also have some topic related to the healthcare domain. So this content training resources are offered in different formats. They are self-paced or instructor-led, and also I will also talk about some educator programs here, because that can we use this program to provide free resource to students. So in our website, NVIDIA website, if you go to the developer.nvidia, then you will find these resources. And for self-paced online course, once you register, you will be able to access some of the online content, and some of them have the GitHub, have the Jupyter Notebook, and the computing resource that you can use. And for more formal instructor-led workshop, that part I will combine that with our ambassador program, because this program needs to be delivered by a professional certified NVIDIA ambassador. And we are working with a lot of different universities, including, and here we work with the NTU, we work with the professors here to, they will become our ambassador, and they will be able to deliver this course for free and access our free computing resources. So here is a quick glance about what this content are about. So for example, for self-paced course, you will be able to touch the topic about the generative AI or fundamental deep learning, or you want to learn more about the accelerated computing. We have this course, you can just go online and check them out. But some of them we need to pay, because this course will provide GPU resources. So, but also some of them are free for our audience. And for the instructor-led workshop, this course cover because it's 8-hour course and it's instructor-led, so you will have access to the Jupyter Notebook and also have the GPU provided by NVIDIA. So this will be a very professional training course. And after this course, we also this instructor-led course also provide some certification that say you are finishing this course, so you will get recognized and by NVIDIA certified for you finish this course, and you are get a certification. You can put that in your LinkedIn or your profile. So these are the resources we provided here, and if you are interested to use this resource, first you can check our online training website. So you can go to the nvidia.com/training online. And also, a lot of resources are required to register. So you can register NVIDIA Developer Program. In this Developer Program, we not only offer these courses, we also have a lot of our previous seminar content. So you can learn, because we have some seminar that is public, and you can review this seminar and to see people talking about different latest technology and computer resources. And if you are educator, you are a postdoctor or professor, you are interested to join our educator program to provide your students different training resources for free, you can join our educator program. And there's also I put the link here. So I think I just quickly introduce some additional resources that you can leverage to help you advance your training, your learning on the AI or your accelerated computing. Thank you. So,
Okay, thank you, Herman. So we have around 3 minutes. So is there any question about either the material I shared or about our DOI material? Okay, so if there is no question, so thank you everyone for your attention. Thank you very much.